We're going on now to page 94 in your supplemental booklet. And again, you can always click on this and scan and get some help through the Math Zone staff. And of course, you can always try it on your own to see how you would do. Let's take a look. First step, read carefully. Clinical trial of a new drug. People are classified as to whether they eat pineapples. That will be set E. Have a family history of high blood pressure. That's set F. Or, and this is key because this is union, are under 18, which will be set G. So to start us off, they're asking us in a kind of a mental Venn diagram, what is G complement? Well, if set G is under 18, G complement would be 18 or over. And perhaps something like this. G complement, people 18 and over. All right, now let's look at F, or B, I should say. So looking at F once again is those people who have a family history of high blood pressure. That is your group F, that will intersect, and the word that we want here is and, G, that are under 18. So just putting this, translating it from the symbolic to the words. So I'm using a little abbreviation. So this would be people with a family history of high blood pressure, and because of the intersection sign, people under 18. All right, let's look at letter C. And hopefully we're giving you a strategy step by step to get to an answer. So set E are people that eat pineapple. And then this is the union symbol, or, and we already did this one up here, people who are 18 and over. Now we just put that into a statement. So something like this, people who eat pineapple, and because of this union symbol, we're inserting the word or, and we did this up here, people who are 18 and over. Now in part 2, we're looking for a psychological experiment. People are classified as to whether they drink alcohol regularly. This will be group E. Have a family history of alcoholism. That's group F. And then are overweight. That is group G, or set C. So again, as we look at these, what will F complement be? Well, have a family history of alcohol is set F. So set F complement will be those who do not. And the key is, if these do, then the complement of F would be those who do not have a family history of alcoholism. Now, as we look ahead to B and C, Again, I think you know how to do it. The key is this is going to be an AND. You'll state what set E is and what set G is, and then you're going to use F complement in union, so this will use the word here or set G. And I'll give you a chance, and then we'll write it out. So, set E are people that have a family history of alcoholism, and because of the symbol and the word, and people that are overweight. That's how you would read that. And then for letter C, we're going to have those who do not have a family history or are overweight. People who do not have a family history of alcoholism, that is F complement, and then because of the symbol union, or people who are overweight. On page 95 here, we could write it there, but I'm going to raise it up. Again, you can scan this and get some help. We're going to answer these questions, and let's read them carefully together. We did that one already. Use basic probability principle to solve the following problem. Express each probability as a fraction reduced to lowest terms. Okay, that's the background. Now we have a 12-sided figure, which is like a 6-sided die, but now it's 12-sided. And what is the set? Well, our sample field are just the numbers 1 to 12. And it's equal outcomes of randomly rolling it. Find the probability of rolling an 8. Well, the probability here of rolling any number, since there are 12 possibilities, is out of 12. That's your sample space. And that you're going to roll any one of these, which is, in this case, an 8, will be 1 out of 12. And if you put all your 1 out of 12s for each number, that would equal the whole, or 1. Now here, a single die, and of course in the normal ones there's only 6 sides. Find the probability of rolling a number greater than 4. Well, what numbers are greater than 4? Well, 5 and 6. So rolling a 5 and a 6 out of a possibility of 6, that would be 2 possible selections out of 6. So here we perhaps shouldn't use a line, but there's our basic ratio. Probability will be 1 out of 3. Again, reading it carefully, basic probability to solve, express each probability. Okay, we know that. So once again, we're having a 12-sided die. What is the probability of ending up with either a 7 or a 5? Well, in your overall sample field, there are 12 items, and you're looking for 2 of them, either a 7 or a 5. That would be 2 out of 12, which would be 1 out of 6. For number 4, let's look at that. Puppies, cute, in animal shelters. There are 8 puppies. And there's a male and female puppy of each of 4 breeds. We have a spaniel, a bull mastiff, a greyhound, and a pulley. Yet I'm not too familiar with dogs. The puppies are so cute that the person cannot make up their mind, so decides to pick a dog randomly. Okay. I might have to read that again. Find the probability that the man chooses anything but a pulley. Well, again, we have 8 possible choices, and he just doesn't want 2 of them, a male or female pulley. So that would be 2 out of 8 that he doesn't want. So if we subtract that from a 1, that's one way to do it. And our 1, remember, is going to be 8 out of 8. We then get 6 out of 8, which reduces to 3 out of 4. Now in number 5, we're saying you conduct an experiment, and the sample space of that experiment is these events that they're saying these are the outcomes, and the probability of these outcomes are listed here. Is the following probability assignment possible for this experiment? Well, we have said that generally the probability of something is going to equal the whole, that is, a 1. Do these partial probabilities of these events equal the whole? Well, what I did is I added them all together, but since you can use your calculator, you can just put this in a calculator, plus this in a calculator, and the rest of these in your calculator. And I got the fraction 190 over 252. And they give you actually a decimal value for this, which is this. So my question here is this only the possible outcomes that can occur? Or are there others that are not mentioned here? Because this does not add up to 1. But could these be possibilities? That is, the sum of these are 1 or less than 1. Yes. And that's what they're saying in our answer key. But again, I'm wondering what they're shooting for here, because in a later exercise that we'll be doing, we're actually going to say if they don't equal 1, then that is not the probability assigned. If these were all of the events and they don't equal 1, then theoretically the answer would be no. But if there were some others, so this is why I'm questioning the yes for this a little bit. Now in the booklet that I have, they have these filled out, but this is what's also in our textbook, kind of a reference to what would happen when you roll the dice. So there's 1. You can get a 1, 2, 3, 4, 5, or 6, and your second die the same. So you want to fill this chart in. If in your booklet it's blank. If not, then and we see the smallest value is a 2. This would be what we call snake eyes, if you are familiar with that. And then if you get a 6 and a 6, the largest number would be 12. Those are called box cars. And notice that 7s go right through the system. And then 6s this way, 5s, 4s, 3s. This line is 8s, 9, 10s, 11. And there are certain patterns, and altogether, you may recall, there are 36, 6 times 6. So a good reference. Now for these, we mentioned this a little earlier. Do these add up to 1? Well, if we see we have a common denominator here of 16, and this will, to make it 16, we're going to multiply it by a 1 in the form of 8 over 8. So this is 8. Going to multiply this one by 4. So this will be 4. Multiply this by 2. So this will be 2. And multiply this by nothing, 1. And it's a 1. So we get 12, 14, 15 sixteenths. Does this equal 1? No. So these, if that's all the possible probability that you could have, cannot be the assigned probability. If these are all the probabilities, should equal 1. So our book for this is saying no now. Now here again, you just add these up and you get 1.01. Does that equal 1? No. So this is a no. And I think you have a strategy for doing this. Going to add these fractions together. Fortunately, 18 is the common denominator, so we have to multiply the 3 times 6, so this will be a 6. 6/18 is 1/3. 4/9, now we're going to multiply the 9 by 2, so this is 8. And then we just leave this as 4. And this is 18 over 18. So that equals 1. So this is a yes. And I think you know how to do these now. This will equal 1.00, which equals 1. So this is a yes. And this equals 1.02, which does not equal 1. So this would be a no. Okay, well, we'll complete this one and then get back to page 98 shortly.